Hello, this is Steven Gazal, and we're going to start our first video on advanced commands in Unix. So this is the fourth and last topic on our module on Bash, Shell, and Unix. During the first topics, we have learned how to connect to the broad server, how to use the terminal. Then on the second topic, we saw how to navigate through files and directories. And on the last topic, we've learned how to view and manipulate big genetic files. So on this module, we're going to see some more advanced commands that you're going to need for your analysis of genetic data. So for example, how to create some function to do not have to repeat all the steps of the GWAS, or to run some jobs on the broad server. So let's quickly go through what we've seen during the first topics. So first, I've introduced you to this sheet of really useful Unix commands, and I've highlighted here in yellow and green what we've been through from topic 2 and topic 3. I've summarized here the commands you should know by heart. So first, there are the commands you need to navigate, pwd, cd, ls, the commands you need to create and delete files and directories, such as mkdir and touch. You need to know at least one of these two commands, vi or nano, to know how to modify files. You need to know the commands to copy, move, or rename files and directories, cp and mv. You need to know some commands to view files, such as less, head, tail, cat, and cut. You need to know what is a wildcard, and especially the star one, and you need to know how to compress and uncompress files. And finally, we saw on the last videos how to combine all these commands together using some pipes. There are also a lot of commands that we've seen and that you should be aware of, but this one, I would say you don't need to know them by heart, and you can report to internet or to the help of this function to know how to use them. So there will be 4 videos for topic 4. The first one to know how to define shell, variable, and functions and do some scripting. And so doing some scripting is super useful when you want to reuse some Unix commands to multiple genetic analysis. Then we're going to see the awk command, which is a command super useful to extract information from really large genetic data. Third, we're going to see how to run jobs, especially how to run jobs on the broad server. And finally, we're going to end by seeing how to use the for, if, and while loop on Unix. So in this video, we are going to see what is a shell variable and how to define it. And then we're going to see how to define and run some functions. So first, what is a variable? So a variable is a character string to which we assign a value. And this value could be either a number, such as 1, 2, 3, 4, 5, a text, a file name, or any other type of data. So now let's see how to define a variable. So first, you need to name your variable. You can pick any name you want, followed by the character equal, followed by the value you want to assign to this variable. So I have to specify here that you are not allowed to use spaces around the equal character. So here we have 2 examples. The first one of a variable called myvar, for which we assign the value hello. And the second one, which is a variable called myCount, for which we assign the number 1. Then, when you want to call this variable, you just need to use the $ character followed by the name of your variable. So for example, here, if I type echo $myvar space $myCount, it will output the value of these 2 variables. So here in this example, hello 1. So if your variable is a number, for example, myCount, you can do some simple computation on this number using the function exp, expr. So for example, if you want to add 1 to your variable, you just need to type exp $myCount plus 1. You can also subtract number, for example, -1, or multiply or divide using \multiply or \divide. So you can also modify a variable. So in the first example here, if you have a variable with some text, you can add some text inside this variable. So in this scenario here, we're going to have myvar, which will have the value hello there. You can also do some computation if your variable is numeric. And so in this case here, we're going to add the number 2 to the variable myCount, and the new value of the variable myCount will be 3. Finally, you can also assign the output of a command to a variable by putting your command between parentheses and by using the $character. So in this example, we have a file which has around 25,000 lines. And what we can do is take this output and assign this output to a variable. And to do that, we just need to type the name of the new variable, followed by the equal character, the $character, and put between parentheses our command. So in this example, you can see that your variable contains 2 values. The first one is the number of lines. The second one is the name of the text file. And it's normal because this is the output of the WCL function. And if you want only the number of lines, you can do some trick and replace the WCL function by using the less function, a pipe, and reusing the WCL function. So when should you use variables? So first, you can use variables to simplify your commands. So here, what you can see is, So here, what you can see are 3 plink commands. So here, what you can see are 3 plink commands that takes a lot of characters. So here, what you can see are 3 plink commands that contain a lot of characters, and that's kind of hard to understand when you see it at first. So what you can do, for example, is create 2 variables. The first one that contains the path to the plink software, and the second one that contains the path to your file. And when we look at the 3 commands now, it's pretty clear what we are going to do. So for the purpose of this topic, we're going to look at 4 different genetic files. We're going to look at 2 files with GWAS results. The first one, which is a compressed file that contains the results for all the variants. And the second one, which is a smaller and simplified file, which contains only the results of chromosome 1. Then we also have a SNP annotation file, which is compressed. And finally, a gene description file. Okay. And so for the purpose of these videos, I'm going to define different variables. The first one, which will have the path to the directory, and the 4 different ones that will contain the path to the different genetic files. So now let's look at how to create functions and scripts. Okay, so first, what is a shell function? So a shell function is a script running shell commands that form a new shell command. So it means that you want to create a new command with a new name that do what you want to do. And so a function is very useful to simplify complex and repetitive tasks. So for example, running a GWAS for one trait. So if you're running a GWAS for one trait, you're going to define a set of commands. And if you want exactly the same GWAS for another trait, you don't want to replicate all these commands. You just want to have a function that automatically analyzes each of your GWAS. So now let's see how to define a shell function. So it's pretty straightforward. The basic syntax is you need to type the new name of your command, followed by two parentheses. You open a bracket, you list your list of commands, and you close the bracket. So in this example here, we have created a command called go home, and that does the following. First, it's going to your working directory or your home directory. Then it's cleaning the history. Then it prints the home directory just as a sanity check. And then it lists all the files of your home directory. Okay. So here, let's say you are in some directory. And now you define your go home function. And so now if you type go home, enter, it's cleaning the history, it's moving you to this directory, and it's printing the list of the files in this directory. So you can, of course, specify some arguments to your function, which means that you can type the name of your function and then specify some parameters such as file names or some numbers, some parameters of your function. So for that, you just need to know that the first argument of a function will be stored in the variable $1 that you can rename for simplicity. And the second argument of a function will be stored in the variable $2. Okay. So in this example, we want to create a function that takes as input the name of a compressed file and that outputs the number of lines of this compressed file because the WCL function does not apply to compressed file. So what we're going to do is create a function called WCGZ that will first output the line of your compressed file using zcat $1. Here, $1 will be the variable with the value of the file you specify as an argument. And then you're going to use a pipe followed by the WCL command. And then every time you will want to know the number of lines of a compressed file, you're just going to use the function WCGZ followed by the name of your file rather than typing every time this command that uses two commands and a pipe. Okay, so now let's see what is a shell script. So a shell script is a text file containing shell commands that form a program. So this is similar to a function, but it's stored in a file and usable by multiple users. So for example, you can share a script between collaborators, but you cannot share a function because a function will run only in your terminal. So shell scripts are stored in files ending by .sh. And shell scripts are simply run as using the word bash, followed by the name of your file, followed by the arguments you want to give to the script. So for example, let's say now that we want to store this WCGZ function into a script, we're just going to create. So now let's go back to the example of the WCGZ function. And let's say that rather than having a function, we want to edit a script that does exactly the same thing. So to do that, you're just going to create a file called wcgz.sh. And the line of this file will simply be zcat $1 pipe WCL. And then when you will run this program, you will just need to type bash, the file to your script, followed by a name of a file. So here I have created a script called wcgz.sh, and what we see what's inside, it's exactly the command I've shown you. And so what I can do is just type bash, the name of the script, followed by some file which is compressed. And this is going to output the number of lines of this compressed file. So this is all for this first video. And now let's meet on the second video to know how to use the awk function to explore really large genetic files.